Binomial expansions. So a binomial is an expression with two terms in it. So an example of a binomial is 2x plus 4. Another binomial might be 3x minus 6. And binomial expansions involve multiplying two binomials together. To multiply two binomials together, we need to take this term and multiply it by this term, this one and multiply it by this one by this one, and this one by this one. So we're taking every term in our first binomial and multiplying it by every term in our second binomial, which ends up being 4 products. Let's go ahead and do that. So we're going to do 2x times 3x gives us 6x squared. 2x times minus 6 gives us minus 12x. 4 times 3x gives us 12x. And 4 times minus 6 gives us minus 24. Here we can simplify because we have two like terms in the middle, minus 12x and plus 12x. Well, they're actually 0 and they're going to go. So we end up with 6x squared minus 24. So if you're multiplying two binomials with an x in both, you'll end up with a quadratic expression. So an expression that involves the trinomial you're dealing with squared. Let's have a look at some more. Let's look at x plus 2 times x plus 3. So again, we need to multiply out every term in our first binomial with every term in our second. So x times x gives us x squared, x times 3 gives us 3x, 2 times x gives us 2x, and 2 times 3 gives us 6. We can add the two like terms in the middle, so 3x plus 2x gives us 5x. We end up with x squared plus 5x plus 6 as our expanded binomial. Let's look at some more. What about x plus 3 squared? There's a couple ways we can do this. We could write it out as x plus 3 times itself, x plus 3, because that's what squared means, and we can go ahead and do that. And we get x times x is x squared, x times 3 is 3x, 3 times x is also 3x, and 3 times 3 gives us 9. We can add our two middle terms, so 3x plus 3x gives us 6x plus 9. This is actually a special binomial when we have 1 squared. We're actually looking at a special result where if we have one term plus another term squared, we actually get the first term squared plus double the product of the term. So the product of a and b is ab, double it, we get 2ab plus the second term squared. So let's do the same example but using this special result where we can do it in one line, x plus 3 squared. So using our shortcut, we know it's the first term squared, so x squared, plus double the product. So the product of x and 3 is just 3x, double 3x, you get 6x, plus the last term squared, so 3 squared is 9. You can see we get the same result as before using that little shortcut. What if it was a minus instead of a plus? So x minus 5 squared. Well, we can still use that same result. We can square our first term and we find double the product. So the product of x and minus 5 is minus 5x. Double minus 5x, you get minus 10x. And squaring the last term, so the square minus 5 times minus 5 gives us plus 25. You could write it out and expand and you'll get the same result. Let's look at one more. 5 outside of x plus 1, all outside of x plus 3. So if we have this situation with a number out the front, we'd like to deal with our binomial expansion first, but we just got to be careful to keep the 5 on the outside. So we'll open up another bracket and we'll just do our normal binomial expansion. X times x is going to be x squared, x times 3 is going to be 3x, 1 times x is x, and 1 times 3 gives us 3. Let's simplify out the bracket. So 3x plus x is going to be 4x. Everything else is not like terms. Now we can expand the 5 out with this bracket. So 5 times x squared is 5x squared. 5 times 4x is going to give us 20x. And 5 times 3 is going to be 15.